Hello DSci 2000. In this video, I will be covering regex or regular expressions. One of the things that you need to be aware of is that I usually prefer base R over string R. So you're going to notice that bias as you see the examples in this section. We had talked very briefly about string manipulation in the last video. However, most of those situations are very simplified situations of what can come up in reality. Here's an example of something that could come up in a job that you can't easily manipulate with what I've presented to you so far. Here's what I want you to do. In the data files folder, inside your DSci 2000 folder, please download from D2L websites.txt and save it to this folder. We're going to go ahead and learn how to read in this text file. Open up your R project file and just close anything you have up. Create a new script. Let's save this in the Unit 4 folder. I call it regex.r. The next thing I'm going to do is I'm going to copy and paste these 4 lines of code into here. And let's go ahead and hit Control S to save that. And just for good measure, go to your DSci 2000 folder, right click it, click Git Bash here, CD to your Unit 4 folder, and git add on regex.r and do an initial commit. To run this code, hit Control A to select all, then Control Enter to run the code. Scroll down, and you can see here that there are 5 URLs contained within this text file. Let's say that your company owns the domain name of fakewebsite.net. And your manager wants you to report on how many users went on pages in this website over a certain time period. And this data right here happens to be a column of data representing your URL. And although it's not shown in this text file, you have another column indicating the number of users that went to these pages. Let's say that you were given these URLs and your boss tells you, tell me how many people went to each website on my page. Here are a few things to take into account. When you look at these URLs carefully, there are really only 2 websites that people have visited within a fakewebsite.net. They are a page called 100 Ways to Organize Your Books, which you can see in URLs 1, 3, and 5, and a second page called 50 Things You Didn't Know About Data Science, which involves 2 and 4. When you are reporting this to people like your boss, you want to make sure that 1, 3, and 5 are all treated as one website, and 2 and 4 are treated as another website. The way that these URLs appear currently is as if they look like they're 5 separate websites. So we have to somehow figure out how do we change these 5 websites into only 2 websites. And that's where string manipulation comes in. The first observation I want you to notice is the following. Website 3 has an HTTP attached to it, whereas the other ones have HTTPS. HTTP and HTTPS are still going to give you the same website. So we have to somehow take into account the fact that this HTTP should be treated the same way as the HTTPS is. The second thing to take into account is that if we were to look at websites 2 and 4, they're almost identical, except for these things after the question marks. They both represent the 50 things you didn't know about data science page, but they slightly differ in that they have all of this extra information attached to it. You're probably wondering what this extra stuff is. What I encourage you to do is open up your favorite social media website like Facebook or Reddit or Instagram or something similar to that, and try to click on a link in that page. What you will find usually is that it will stick a question mark with a bunch of stuff at the end of it. This stuff with the question mark and the things after the question mark are called UTM tags. UTM tags are what marketing teams use to track their sources of traffic. For example, in number 2 right here, this is an example of someone who visited this 50 Things You Didn't Know About Data Science page, who came from Facebook through a campaign called Data Analytics. And the campaign's type is cost per click. I'm not going to go into all the details of what a cost per click campaign is, but these are just things that you should be aware of that marketers use to track the types of traffic that reach you. The 4th website right here is someone who went to the same page, 50 Things You Didn't Know About Data Science, but they came to this website from Google through the same campaign, the cost per click campaign called Data Analytics. So when trying to combine 2 and 4 together, considering the fact that they are the same exact page, we don't want any of this information from the question mark onward in both of those URLs so that we can combine them together. That's the next thing we have to take into account. The third thing to take into account is that number 5 has those UTM tags attached to it as well. Someone went to 100 ways to organize your books from Instagram through the same data analytics cost per click campaign. But on top of that, someone, when they went to the same website, they added a slash at the end. And in number 1, no slash was added at the end of the URL. Yet at the same time, 1, 3, and 5 are treated as the same URLs. So we have to somehow reconcile the fact that one of them doesn't have a slash, the other one has HTTP with a slash at the end, and the 5th one has a bunch of UTM tags at the end. We have to somehow turn these all into the same URL so they can report the stats to your boss. Just to summarize what it is we're going to have to do. We're going to have to match this HTTP to be the same as if we had the HTTPS somehow. We're going to also have to get rid of these UTM tags at the end of the URLs. And we also have to treat this slash here as if the slash weren't there because it is still going to the same page, regardless of whether the slash is there or not. And that's essentially what this slide is saying. So we've laid out some stuff that we want to deal with. And the easiest way to deal with that would be to use sub, choose an appropriate pattern, and then substitute the pattern for a zero-length string. So basically, choose stuff that you want to toss out, and then just keep the essentials at the very end. However, one of the most difficult things is going to be this. Let's take these UTM tags, for example. These UTM tags vary for all 3 of the websites for which they appear. Namely, 2, 4, and 5 have completely different UTM tags. On top of that, they all come after variable strings. This one comes after 100 ways to organize your books. This one here, number 4, comes after 50 things you didn't know about data science. So, the methods that I showed you in the prior lecture are insufficient to address these variable strings. And for that reason, you need regular expressions or RegEx. Here's some XKCD comics that I encourage you to read regarding RegEx. I want to also mention that RegEx is not limited to R. There is RegEx, for example, in Java and Python. Regular expressions are one of those things that you should learn how to use. They will be extremely useful no matter what programming language you program in. One of the most famous quotations about RegEx is this famous quote by Jamie Zawinski. He says, "Some people, when confronted with a problem, think, I know, I'll use regular expressions. Now they have 2 problems." The point of this quote is this. RegEx is tough. Try to avoid it when you can, and use it sparingly when necessary. However, there are just some cases like this one where you just can't avoid it. Also, take into account that we're going to have to perform multiple RegEx steps with the cleanup that we proposed. Problems which involve RegEx can be rarely solved in just one step. There's a website that I recommend here for RegEx testing. There's a cheat sheet available there that's very nice as well. And honestly, I am not an expert at RegEx. I still look things up whenever necessary, and I encourage you to as well. My only intent with this lecture is just to introduce you to RegEx, because most programs do not cover it. So this is just summarizing again the things that we wanted to do with the URLs that I mentioned earlier. Let's go through every step and show the RegEx that we would have to do for what it is we want to reconcile. So the first thing I'm going to deal with is the fact that the first and third websites are similar, except one of them has a slash at the end and the other one doesn't have a slash at the end. So I decided in my slides that maybe a plausible first step would be, let's get rid of slashes at the end of a URL. And how you would do this is using this code right here. Let's go ahead and copy and paste this code under our currently existing code. And let's press Ctrl Enter. Go down to the console. If I type in websites again, I can see that the slash at the end of that string has been removed. And just as a reminder, this here is the syntax that we use to say at the end of a string, if there is a slash, remove it. This code right here is RegEx. This here is just your usual substitute a zero-length string in place of whatever is in the prior argument. Let's go through what that RegEx means. Here's what that RegEx means. It means look for a slash, that's where the slash comes from, at the end of the string. The dollar sign in regex refers to the end of a string. So in other words, this is saying, look for any string that has a slash at the very end. So that's how R knows to look at this command and say, okay, look for a slash at the very end of a string, and then substitute it with a zero-length string, removing the slash in that situation. Analogously, the caret, which looks like this, is the indicator for being at the beginning of a string, as opposed to the dollar sign. The one thing I want to remind you of is that one case where website 3 has an HTTP and everything else has an HTTPS. How am I going to get around this problem? I know that all these URLs are at a fake website.net. So honestly, I don't need anything from the HTTP or HTTPS all the way to a fake website.net with the slash. So I could just remove everything that's prior to the slash right after a fake website.net. And the way I would do that is using this code right here. Let's go ahead and copy and paste that code. And I notice here that this didn't paste correctly. If you were to look at the slides, these should both be front slashes. Put our cursor at the end and press Control Enter. Let's scroll down. If I type in websites, I can see that any string that had HTTP or HTTPS with a fake website.net with a slash has that part removed completely. And I'm comfortable doing that because I know that all of these are from a fake website.net. So this here was the regular expression we did to tell R, look for HTTP or HTTPS with slashes and a fake website.net, and then replace that with a blank string. That is the regular expression that's being represented here. Let's go in depth and explain what this is doing. So the first thing you need to know is that periods in regex are used as one character wildcards. So therefore, if you want to use an actual period, which happens with the .net at the end, you must escape the period so that it's not treated as a one character wildcard by escaping it with a backslash. So this is a construction in regex that you use to say, I want to match an actual period. However, what complicates this a little more is that if you want to use a slash in R, you have to put another slash in front of that slash. So this construction right here is just saying, look for a string that has a period in it. That is what you have to do in R when you want to use a regular expression with a literal period. If you do not have the slashes with the period will just be treated as a wildcard. So that's the first thing that's going on here, is this literal period that's here. Another thing that's taken into account here is this. Some of the URLs have HTTP and others have HTTPS. So to take that into account, we see this construction right here. Here's what this is saying. Look for the string HTTP and then look for 0 or more of the letter S. So the asterisk in regex refers to 0 or more of the prior character. And we are emphasizing that the character is on its own by surrounding it with parentheses. So in other words, here's what the regex is saying. The regex is saying, look for the string HTTP, 0 or more S's, then here is just the literal string : / a fake website, then a literal period, and then net with a slash at the end. So that's what it takes to tell regex, look for that first part of the URL, regardless of whether or not it is HTTP or HTTPS. Where are we right now? We're almost at a point where these values have been compressed into two distinct values. The only thing that's remaining are these question marks and UTM tags at the end of the URLs that we want to get rid of because they don't tell us anything about the actual page itself. There are only 2 pages and we don't need the UTM tags. The last thing we need to do is we need to tell regex, look for a question mark and get rid of anything after it. How do we do that? The code for that is this right here. Let's go ahead and copy and paste that. And I can see that it didn't paste correctly. That NN should be replaced with 2 slashes. Press Control Enter and scroll down. Let's type websites again. And now we can see that we've now achieved what it is we wanted, which was to turn those 5 distinct websites into 2 websites. This here was the regular expression that said, look for a question mark and anything after it, and substitute a blank string in place of that. Now let's explain what this regular expression is doing. So the first thing you need to know is that the question mark in regex actually has a function. I'm not going to cover what that means, but similar to the period, to avoid having to use the function of the question mark and use a literal question mark instead, we escape it with 2 slashes, just like we did with the period in the prior regular expression. So that's why we have the 2 slashes and a question mark. The second part of this is a period and a plus sign. The period, remember, ordinarily, without the slashes before it, is a 1-character wildcard. The plus sign after it means to match 1 or more of the prior character. So what the period and plus sign mean is look for 1 or more characters. And it doesn't matter what characters they are because the period is a wildcard. So therefore, what this entire regular expression means is find a question mark and then look for any character after the question mark. So that's how R knew to take these strings, look for a question mark and anything after, and just put a 0-length string in place of it. So, looking back at the code that we had to write to get here, this is how much work it took. As you might imagine, it's not easy to know what sequence of regular expressions you should use to try to manipulate strings. And I don't expect you to know all of the nuances of regex in this class. You should at least know what these basic constructions are and what they do. If you want to get better at regex, you must seek help and you must practice it. Now, let's go ahead and save our code. Hit Control S. Let's go to Git Bash now. Do a commit. And do a git push. Let's close Git Bash. Go to the right of RStudio. Close RStudio. I don't want to save the workspace. And we are finished.